Okay, so I thought I'd create a video on how to submit a package to the Arch Linux user repository, or AUR. So if you aren't familiar with Arch Linux, AUR is a repository of user-submitted packages. So for example, I can search for my own package here that I've submitted, S3 rename, and I have it here, and I'm able to kind of install that with EA directly or other AUR installation tools. So this is a really easy way for users of Arch Linux to submit and share packages. Now, on the AUR, there are kind of different types of packages. So searching here for Jellyfin, just as an example, we see there's a standard Jellyfin package. Now, this will compile from source, but to a particular release. There's a Jellyfin bin package, which will be the binary of a specific release. So that won't actually compile from source, but will just copy over the binary. And Jellyfin git, which will compile from source, but pointing to the latest revision in the repository. So these are kind of the different types of packages. And in this video, we'll look at creating a git package. So a package that points to the kind of latest code in the repository. And the package we'll use is this alma package. So in the last video, we worked on submitting some features to alma. In fact, you can see the closed pull request here on the merged pull request. But as you'll note, here we have the releases, which is what the version on the AUR is pointing to. So if we search here in the AUR, we see AUR alma 0.10.0/1. And this corresponds to this release back in kind of the end of 2019. So we'd like to kind of be able to just create a package kind of straight from the Git repository, so we can install the latest code without having to kind of create a new release and bug the maintainer to do so. So let's have a look at how we'll do this. So in this case, what we want to do is create a Git release. Now, the AUR, so the way packages are built is with package build files, and we can actually view the package build files for any existing packages in the AUR. So here's one example, is bat-cat git. So bat is a replacement for cat, also written in Rust. And in this case, this is the kind of Git version. The reason it's called bat-cat here is because another program called bat already exists, the binary analysis tool. And so they call this bat-cat so the packages, so the package names don't conflict. So let's have a look at their package build file here. So here we can see they specify kind of the actual package name for the AUR has to be bat-cat git, as I mentioned, and then kind of this pseudo package name is just bat, and which they'll then use kind of throughout the package build. So the most important things here are the SHA-256 sums are set to skip, because you can't verify. So normally if you have like a source package or a binary package that's pegged to a release, when you create the package build, would go and take the SHA-256 checksum and put that in the package build file, so that when a user then goes to compile from source or goes to get the binary, that is checksummed, so they know they have the same binary or the same source code that you intended. Obviously, in the case of the kind of pointing to the latest revision in Git, we have no idea what that'll be. That'll be constantly changing, and that's what we want. So in this case, we just skip the checksum. We also need to give it the Git repository and tell it kind of what command it provides. And that's everything. Strangely here, they don't actually have a conflicts entry. I was expecting there to be a conflicts entry with that, kind of with a binary analysis tool, so you don't install two binaries called bat with the same name that then conflict with each other inside the binary directory, but apparently they don't. So let's actually have a look at what provides does. So here is the Arch wiki page for the package build syntax, and here we can see kind of everything that's specified here. So here we can see the different entries like package name and so on, and we want to look at provides. So package relation provides an array of additional packages that the software provides the features of, or a virtual package providing the same item can be installed side by side unless one of them uses a conflicts array. alternate versions. Okay, so that's interesting. So here's an example, right? So provides NetBeans as a package itself, provides NetBeans and conflicts with NetBeans. Provides NetBeans and conflicts, but does not need. Okay, so this is basically a way for Pacman to work with exactly this case where you might have multiple packages that conflict with the base package, but for example, NetBeans PHP doesn't know about the existence of NetBeans Java SE, and so Pacman basically needs to kind of work out that these two are in conflict, despite them not knowing about each other and only knowing about the base NetBeans package. So we will also need to provide a provides entry in this case, and also kind of a conflicts with the Alma base package that already exists. So we'll do that. So this is the package build for Git. We also have the current package build for Alma. So let's have a look at this. So this is the package build pointing to the release, and we can see that here. So we have the source is this tar gzip tar file. This is the SHA-256 sum for that file, and it's kind of pointing to this URL, and somewhere here, yeah, we see $URL archive. So it's grabbing this from the release, basically. So from the GitHub releases, it goes and grabs the source file, which we can see here. If we go releases, so this source code tar gz file is what it downloads. It extracts that and gets the source code from that, and then builds it. So we basically want to kind of combine these two files. So we can start with this as a base and then work out what do we need to change to basically make it point to the latest revision, check that all works, and then submit it to the AUR. So let's get started. Let's create a directory. So we'll call it something like alma-git. Okay, so let's start by just copying this file over and then making some changes here. And then package build. Okay, so first of all, I'll update this. And enter my email here that's both public on Crates.io and on the AUR, so there's no problem there. So package name, now this should now be alma-git, right? So one interesting thing here is, do they actually use this other package name? So they use it here because all the files, so the repo is just called bat, clearly. It's not called bat-git, right? So we will also need to do this. So let's actually just copy this again. And let's put this in quotes just in case. So this underscore. Okay, so this is fine. So the package version is interesting. I wonder, like, it seems like this isn't actually used, right? Because we have this package version here. So in the end, we're going to want it to just be the latest Git revision. Probably what we should do is run this command inside the repo and find out what version we currently have and put that there. So we'll do that in a moment. For now, we'll leave it as it is. So package rel, what is that? So package rel is the release number. Differentiate between consecutive builds of the same version of the package. Okay, so this is like if we update the package build, but we don't update the package version, it allows us to kind of like make sure the changes in the package build are used by kind of anyone who pulls this down from the AUR without having to modify the package version. So basically it will realize it's kind of updated the package build without actually having to be a different version of the package. So we don't need to change that right now. This is the first kind of version. Maybe we will if we have some mistakes, but for now we'll leave that as is. x86-64 is fine. So these are all fine. The URL is also fine. The license is fine. So we depend on Rust just the same because we're still going to compile from source. So all of these stay the same, and the source changes. So let's just put this here. So we get rid of this, and this becomes underscore package. I mean, here, like, it's like we've written this here, right? But in the URL, we still have alma kind of written out, so we could just write it. But we'll leave it as it is, just to have the same syntax. So now here, we need this to provide that, which obviously going to be provides alma. And now, I think we need conflicts with here. We'll see whether that creates any problems later on. But I mean, we should never have both versions installed at the same time, right? So I think it's fine to do that. So where was that here? Just check this syntax quickly. Conflicts. I suppose in example here, never mind. Just conflicts like this. So provides alma, provides and it means provides and it means conflicts and it means. Okay, so that all looks good. And this we need to change it to skip, and we can see an example of that here. Okay, so we skip that. Now in our case, so we need to sort out this package for things. So let's just copy this. So put that there. Sort out the syntax a bit. Okay, so this is fine. Now the build is going to have to change, right? So we're probably going to want to copy this here, and then we're going to need to work out, like, do we create the source directory properly? Or do we even have? I mean, this isn't specified here, right? So the source directory must be something that that maybe it's here. Let's have a look. Source. Okay, it's not. So it must be something provided by make package when it's actually creating these. So let's just put that there for now, and we'll see whether it works or not. And now this is much the same. So we do this, we cargo build release. We don't have any assets or anything special. And then to package, we're going to want to do this again, because we no longer have like a fixed package version, right? So we don't want to use the package version here, which means we're going to need to check this. Let's just bring this over a bit. So we copy the license file to the licenses, and we copy it to user bin. So that's fine. Now we're copying package name. This should now be underscore package name, right? Because our binary we were called alma, not alma-git. In fact, you can see an example of that here, where they have it in fact exactly this case. So we also make sure this is executable as well. So okay, that all looks good. So we'll test this shortly. So let's sort out this package version. So to do that, we want to run this command, this whole command, inside the repo. So let's do that. So let's go here, go to a new window, go to the repo, which will be in. Because I don't want. I mean, I can use my fork, but I don't necessarily want my fork. But yeah, do I have this anywhere? Yeah, cool. So let's pull down the latest changes and check on the latest version we are. So then let's run this, and let's maybe run this in ZSH so we don't have problems with. Okay, but that doesn't work. So we might need to. So the problem is fish will try to like make these fish variables, which is why I'm having to. Yeah, what is it wrong here? Maybe I do need these. Now we're going to have to run it in ZSH. So what's the easiest way of doing this? So the problem is, because I'm running in Tmux, it's like this isn't available inside. Like inside of ZSH. So this is really irritating. So I can't paste. Let's see what's an easy solution to this. Okay, we come out here. Let's just create a file temporarily and do it this way. So just do bin. So let's just put like revision.sh this, and put this here. Okay, so this is our latest revision. This is what we'll put as the kind of current version, but it shouldn't really affect us because we have this package function anyway. Okay, so this all looks good. Oops, I forgot to change this. So this needs to change to hard-R-ish. So we provide alma, we conflict with alma. Our base binary is going to be called alma, but our package name is alma-git. We have all the same dependencies, all the same build process. We need to make sure that this source does stuff works out okay. This when we kind of git clone it will be in alma, so that's fine. And this is wrong. This needs to be underscore. This also needs to be underscore. I wonder, do we need to put this like does it work with the underscores here? Let's check this example here. So that they put it in square brackets, curly brackets even, so we'll put it in curly brackets as well. Yeah, we'll do the same thing properly. So save that, and now just double check it again. So basically everywhere we should be using kind of the binary name, like underscore package name, and package name is basically only for the AUR, that this is going to be alma-git. So all the rest of this seems okay. So now we can try to actually build this. So let's close this down. Okay, so we have our package build file. So now we need to kind of build it and check that everything builds okay. So if we come here to creating packages in the wiki, we can find an example here. So there's kind of two things we need to do. We need to build it and make sure it works. Then we want to run namcap and make sure we have all the dependencies. Things like OpenSSL, it will check that you have it as a dependency if you're going to dynamically link to that. And then the other thing we need to do is generate this source file, which I can't see here. So, but we'll check that in a minute. That's kind of the final step. So let's just run this to make sure it works. So if we just run the package here. Okay, so it pulled down the code, it compiled it, so at least the directories are set correctly. And let's actually see here, while we're waiting, if we can find this source thing. And certainly there's that source there. So these are given to you by, so that's fine. So this all seems okay. But what we need to do is generate this like .source file, whatever it's called. Actually, while we're waiting, we can check another example here. So if I go to the previous package build I've made, remember what it's called. So here I have what I used to package S3 rename, and if we go to like sort S3 rename here, so here we have this this .source info, and this is like a version of the package build file, but basically like formatted in a way such that it can be easily parsed. and we need to generate this file. So it's .source info. So let's do search here, source info. It has its own page. Okay, so we need to remember to generate this before we submit to the UI. This has to be in this kind of final repo we create. That's the one that we actually submit. So we'll keep that in mind. And for now, let's just have a look at this. Okay, so built, it seems like everything works. One thing we can actually do is run installs in a packages alma-git. So it's interesting that it puts the thing on the end. We probably don't want that. And it also doesn't seem to say that it conflicts with alma, which is interesting. So both of these seem like it could be problems. So our package name is only alma-git, but our package version is this. But again, that's only the package version, right? So that should be fine. I mean, maybe this is correct. It's been a long time since I've installed like a Git package. Let's leave it as is for now and continue with the numcap side of things. So here we have all the files in the directory. So we want to run numcap against the package build. Okay, so we need to add Git as a dependency. So this is why it's really useful, this tool. And let's run it against the alma-git thing. Dependency included and not needed. So these are definitely needed, right? So it might not be needed in the compilation step, but it's definitely needed to run Alma. So that's okay. So I mean, these unused ones, like they're only warnings, it's not really an issue, but we need to fix this missing Git dependency. So presumably here they have Git. Yeah, they have Git as a dependency. I mean, we don't need anything else, right? We don't need bash. So they have like bash instead because they're running these scripts, right? We don't need any of that, but we obviously need Git to actually clone it. Then we need Rust for cargo, and that's it. Everything else is just standard. So let's add in the make depends. We need to add Git. Okay. Okay, so no hidden files here. So let's just kind of RM everything that isn't the package build file. And now let's make package again. It'll take a while to compile. So in that case, we should test installing it and make sure that all works okay. The problem is I don't think we bumped the version, so it might be difficult to actually work out kind of what version we have installed, although we can check it from the help. So because we've added new features in these recent commits, if we check the help of Alma, we'll be able to say, okay, which version are we actually running, to make sure this conflicts is working, to actually overwrite the version I have installed otherwise via the AUR, which I think I have installed via the AUR. I mean, it could be I only have it installed compiled locally. I don't have it installed via the AUR. Maybe we should check that as well. So if we go here, let's just use this window. Okay, so I don't actually have it installed because I installed it via cargo to install it locally. So actually we won't get a conflicts message, which is fine. Maybe let's force a conflicts message by actually installing Alma. Let's just type to go. So now this is also going to have to compile. It's a lot of compilation. But now when we install, we should get this kind of conflicts message and replace it, which is what we want to verify that works. So let me just wait for one of these to finish. In the meantime, we need to double check this stuff with numcap again so we don't have any issues like that. And then we're almost done, really. Then we just need to actually create this kind of final repo, generate the source info file, and push it to the AUR. Okay, so I'll wait for this one to finish before I try to install this. But at least this will generate kind of everything we need. So now let's run memcap again. Okay, so we get some warnings, but those dependencies are needed because we need these tools to actually run Alma. And now we get no errors in the package build, so that's good. Okay, so with all that in mind. Okay, so now we kind of have everything working. We need to generate the source info. We need to basically put the package build kind of into this AUR repo. So let's do that while we're waiting. So we need to actually generate the AUR the repository in the AUR that we're going to push to. And let's see if I remember how to do this. So basically, you clone this repo even though it doesn't exist, and that triggers it to create it and ties it to your account. So in the AUR here, if I go back this minute, so bigger, make this a bit bigger here. So here I have, I go AUR, sorry, my account, so here you have an SSH key, you add your public key here, and that ties it to your account. And so that is what works. So now when I go to clone, this repo doesn't exist. It's like, oh, it doesn't exist. I'll create it and tie it to your AUR account that it knows because I've added my public key here. So that's kind of how things work. It's very impressive. And so let's do that. So the only other thing we need to do is actually create, so not creating a package, like submitting to the AUR. I'm not sure which page this is under. So submitting packages maybe. So AUR submission guidelines, creating package repositories. So here it kind of has everything. It's like authentication and so on. Making sure your packages were written, adding the kind of maintainer names and so on. But also here we should probably add at least. Let's actually do that as well. So if we go and do package build, let's also add the kind of original creator here as a contributor. I mean, maybe this should be vice versa since he's really the maintainer of the package, but I'm the maintainer of this, the creator of this package on the AUR, so we'll leave it like that. So, where are we? AUR submissions. Okay, we have the SSH key pair done already, and so we need to do this. We need to create this repository, so let's do that now. And actually, before we do that, so we've now installed the normal Alma package. If we now try to install this, we should get, so alma-git and alma in conflict, remove alma. If I say yes, then it will remove alma. We've removed alma, now put alma. Actually, let's just check we're using the right one. Alma help, that's all good. Go to alma create help. And now we can see we have this AUR packages stuff, which is the kind of feature we added in the last video. So this means it's definitely pulling from kind of the latest commit. So that's good. So that's all working. So now the only thing we have to do is actually submit it to the AUR. So let's find this here. So this is this trick with the git clone. So let's just check where we are again. Okay, everything's good. So let's copy this properly. So now this should be alma-git. Okay, it tells us, yep, we can do empty repository as we want. Now the only thing we need to still generate this source info file, right? So let's do that now. So that's all good. We have it, obviously it's -a. Okay, we can see it here. It's a hidden file. So now we have our alma-git. So this is kind of the final thing that we're going to push to the AUR. So we need to copy our package build here. We need to copy source info. Yeah. Okay. So we have our final files here. We have everything working. So this is the first push. So that should all be fine. And we'll just leave it with our name and email. That's all fine. So this is all done. So then we just go commit alma-git first versions like this. Oops, I've got the files. And git push. Okay, so that's all good. So now if we wait a moment, we should be able to see this on the AUR page itself, right here. So it should even appear under my packages. So here we have alma-git. And now let's just check again that we can kind of install this. So if you know the ss alma-git, we should see this. Yep. Let's just read that. Obviously, in our case, already installed, so let's uninstall this. Because we installed it with make package. And now if we go ss alma-git, ss alma, let's just check everything. Oops. And now we see our alma-git up here. So we have kind of the alma-git version and also alma down here. So we have both. We can install the latest version, and kind of anyone can come here, run install alma-git, and oops, this needs to be yes. And it would install and copy it to user bin, and everything's working. So now, I mean, let's just wait for this to compile again. And so you really see just how easy this is, right? So there's kind of just 2 pages you really need to look at. They're creating the packages for the syntax of the package build, and bear in mind that you can look at any existing package build files to have a good idea of what you need to do. And then we have also kind of this creating packages page, and then finally kind of the AUR submissions for actually submitting to the AUR. It's all very easy. Like you create your user on the AUR, you add your SSH key, and you create the package build. And so this whole process can be done in 10 or 15 minutes, and the majority of that is just testing to make sure that everything works as you want it to. So that works really well. The main thing to be aware of here is to be very careful that you have all of the dependencies you need in the package file. So for example, to go back here to look at that, if I remember rightly, this is missing the clang dependency, although it seems to be added now, right? Yeah, they have clang here in mate events. So if you miss a dependency, imagine if you have it installed on your local system, you might not notice, and that's why you want to use kind of that namcap tool, or even create kind of a new ch root and test your package there, so you can be sure there's nothing that you're missing, right? Because here you don't know what other people are going to have installed. If someone doesn't have Git installed, we need to make sure that it installs Git. And so this is one of those cases. So for example, here, like in the case of Alma, crypt setup, specified as an optional dependency, but it's necessary if you want to do full disk encryption, which is an important part of the actual tool. So let's just check this. Yep, we're all good. And we did not bump the version. So at some point we should bump the version and actually create a new release as well. But for now we have a way that people can still use this tool, and kind of what happened to use Cargo and manage it all themselves. Although bear in mind this still installs from source, so perhaps it'd be worth also creating a binary package at some point. But that would need to be pegged to releases that release with a binary version. So hopefully that's been useful, and now you can see just how easy it is to create a package with AUR. So if you like this content, please subscribe to the channel, and thanks.